This tutorial covers 2D analysis in planes that are not perpendicular to the camera axis. It assumes that you have covered the depth scaling in the 2D with TEMA Automotive and Coordinate Systems tutorials. There are two ways to handle angled or skewed planes. The first method is to have 4 points in the plane and have their coordinates imported or entered into a target model. The second method is to assume that the plane has a known angle to the camera axis and to use only 2 reference points in the plane which are a known distance apart. The example we're going to use has 4 reference points, P1 through P4, on the vertical member. There is one moving target in the same plane, point 1, and another moving target, point 2, in a parallel plane behind the first one. Starting with the first option, we need to establish a target model for the 4 points in the reference plane. We can do this by entering them into an ASCII TGT file. This is the format for that file, which can be generated in any text editor such as WordPad. Now import the TGT file, making sure you have the correct units. Here you can see the ASCII file and the TGT file inside TEMA. Now when you save it, you will see the 4 points brought into the points list, points 1 through 4. Now you can manually import any other points you want for moving targets, in this case point 1 and point 2, and having imported the reference points you need to attach them to the targets in the image by tracking them. This can be done manually in one frame for a static coordinate system, or by automatically tracking them in all frames for a dynamic coordinate system. Going to the motion planes option, we will select a 4-point system and a static system. We must identify the 4 reference points by name, and we must also define the offsets to parallel planes, in this case only point 2. Thus the target model has provided the coordinate structure. Usually, as here, one of the points is 0, 0. Now we have tracked the 2 moving points, one of which is in the same plane as the reference targets, and one of which is moving in a parallel plane further back. They are both moving together with one driver. Needless to say, we now have 2 parallel planes, each with its XY coordinates. So we have plots of motion and velocity both superimposed on each other in the 2 parallel planes. Now moving to the second method by defining the plane angle. In the multiple planes option, we need to define a skewed and then a static system. We need to identify the 2 points, P1 and P3, and the distance between them. Then set up the angle of the plane. Finally, we need to set the offset for point 2, which is in the second plane. Now we need to go to the coordinate system and set up a coordinate system using P1 as the 0 point and P3 as being a second point which defines the axis. After tracking, we have again 2 superimposed curves.